Okay, so we're going to determine the coefficient of variation, and it says assume the average of an MBA student is 30.4 years old with a standard deviation of 2.7. So here we are talking about a population. It doesn't mention anything about a sample here. So remember how to calculate coefficient of variation. So our top value is sigma, which is population standard deviation. Our bottom value is mu, which is population mean. So we're going to do 32.7 divided by 30.4 times 100. We're going to round this to one decimal place. So when you do that, you're going to get 8.9%. So that is part A. Okay, the next part is the z-score for a 28-year-old MBA student. Well, 28 is below the average, the mean here. So we should get a negative z-score. So you're going to plug in for x 28, the population mean is 30.4, and you're going to divide that by 2.7, which is the population standard deviation. And we do get a negative z-score because 28 is below the mean. Okay, for part C, we have to use the empirical rule. Let's talk about the empirical rule for a second. According to the empirical rule, if a distribution follows a bell-shaped symmetrical curve centered around the mean, this is what we're going to expect. 68% of our values are going to fall within one standard deviation from the mean, either within one above or one below. And then for 95%, the values are going to fall within two standard deviations of the mean. And then 99.7% of the values are going to fall within three standard deviations. So you kind of just need to memorize that 68% are going to fall within 1, 95% are going to fall within 2, and 99.7% are going to fall within 3. So we're going to use the empirical rule to figure out the values here. So the way that you're going to do that is 68%. So that is 1. So Z is going to be 1. Okay, if it was 95%, it would be 2. And if it was 99.7%, it would be 3. Because remember, Z tells us the number of standard deviations. So what we're going to do is we're going to plug in everything into our formula, what mu is and what the standard deviation is. Okay, so mu and the standard deviation were given to us. All we had to do is figure out that Z is 1. 68% of the values are going to fall within one standard deviation. So we're going to do 30.4, and I believe this should say plus and minus here because we're going to do above and below. So we're going to do 30.4 plus 1 times 2.7, and we're going to do 30.4 minus 1 times 2.7. So let's get those two values there. Okay, and we're going to write these in interval notation because we want to know the interval of what numbers they're going to fall in between. So the way you would write that is you would put 27.7, which is going to be on the left side of the mean, and 33.1, which would be on the right side of the mean. So what that means is 68% of our values would range between 27.7 up to 33.1. Okay, for the last part, it's probably the most difficult part in this section. It's Chebyshev's theorem, kind of hard to say. And this is what the theorem states. And you can use this regardless of the shape. Remember, for the empirical rule, it has to be bell-shaped and symmetrical. But Chebyshev's you can use regardless. So this is what it says. Their rule is 2, 3, and 4 standard deviations, and their percents are 75, 89, and 94, which I don't expect you to remember that. But here we're working backwards when we're using this formula, because we are looking for in part D the range for 95%. So what we're going to do is I'm just going to show you how to set this up with it already solved out the way that you need it to be. So you may want to jot this down. When you're trying to work backwards, you're going to say 1 minus 1 over z squared. So 1 minus and I wrote that wrong, but basically I have already solved it for where you can just plug it in, and I believe R percent was 95% in part D, so 95. So what we're going to do is we're going to do 1 minus 1 over z squared equals 95. And then what we need to do is solve for z squared, or get z. So we need to subtract 1. Okay, so that would be -5. And I believe this is a 0.95, so that would be 0.05. And that would leave us with -1 over z squared. And then we can basically, I like to cross multiply here, but let's see how they want you to work it. They want to multiply both sides by z squared, so that's basically what we're doing. We're getting rid of z on the denominator by multiplying both sides. So you end up with -0.05 z squared equals -1. Now divide by -0.05, and z squared would equal 20. So we're going to take the square root of that. So z is going to equal 4.47, and I believe we are going to round to 2 decimal places. Okay, but we still, that's just z. Now we have to take z and plug it into our formula. Remember your formula up here? I'm going to move it down here for us. Okay, so mu is 30.4 plus z, which we just got as 4.47, times the standard deviation, which is 2.7, and we're going to do that for the lower value by subtracting, and plug that into your calculator to get your interval. Okay, and you're rounding to 2 decimal places, so our interval would be 18.3 to 42.5. Okay, and then the last one is, we're doing Chebyshev's theorem again, but we're doing 79%. So what you would do is, you would put in 0.79 into our formula, and remember, this is solved out so we can solve for z easier. So when you do 0.79 minus 1, you're going to get -0.21. So -0.21 is going to be in front of z squared. and you're going to divide by 0.21 negative to get z, and you're going to get 4.76, and then you're going to get the square root of 4.76, and I believe we are, it does say round to 1 decimal place is needed, so I need to make sure. Okay, I can look at the example, and so that's what you have to be careful about. Round to 2 decimal places until you get to the end. So 2.18, and then we're going to do x equals mu plus and minus z times the standard deviation. Well, mu is still 30.4. And I'm not going to write plus and minus separately this time. Z is going to be 2.18 this time. And your mean is, your standard deviation is 2.7. So let's plug that in. And remember, when you get your answer in interval notation, round to 1 decimal place. Okay, and you'll get 24.5 and 36.3. Let me know if you have any questions.